YouTube, this is Umozo3. In the previous lesson, we started talking about something called an enumeration, which is very similar to an iterator. The only problem is that it's worse, okay? And so that's why we basically don't really need to bring it up and be too familiar with it, but why not have more techniques rather than fewer at our fingertips? So anyway, we can go ahead and look back at this example class, which we've been using for several videos now. And at the beginning of this lesson, we can go ahead and remind ourselves that we need to import some important classes from Java. So for example, if you want to call static methods from the arrays class, you need to say import java.util.arrays. If you want to use a hash map, create a hash map, you need to say import java.util.hashmap. Okay, but the two very critical ones in this lesson are going to be import java.util.Iterator and import java.util.Enumeration. And while we're at it, I'll probably remind us of this later, but we could also say listIterator. So we're going to come up with another iterator, another way of iterating through the elements in a particular array list or linked list or some other similar data structure. But what we're going to do is we can go ahead and review iterators and enumerations again, and then talk about one more technique that we have available for iterating. But what we can do is we can basically, we've been talking about vectors a lot, so we can go ahead and let's talk about stacks again. So we're talking about stacks, so we could say import java.util.stack. And then we could say basically, let's do a stack of doubles. So we could say stack of double, and then you could say numbers equals new stack of type double. And so then this is how we declare and initialize an instance of the stack class, right? We're just creating a new stack, right? And then we could go ahead and push elements onto the stack. So you could go ahead and remind yourself of how the functionality for a stack works, right? And so you go ahead and go into the Java API for a stack class, right? And so the stack is a last in, first out stack of objects, right? And so essentially there are 5 operations here that allow you to treat a vector as though it were a stack. But the point is that you can look at the top of the stack. You could remove the top of the stack while returning it. You could see if the stack is empty, right? We just call empty rather than is empty. Okay, and then you could also push an element onto the top of the stack. And if you do that, if you say x equals stack.push of w, basically that would go ahead and set x equal to w, right? So it just returns the element that you're adding onto the top of the stack. Okay, and then we can basically, and so that's the push, right? And so that would return the item argument. What you know, it just returns whatever you just added onto the top of the stack. And then you could also search for an element on the stack, right? So if it was at the top of the stack, then you would get a 1. If it was 3 down, you would get a 3. If it was 9 down, you would get a 9, right? But hopefully that's clear to you. And so it's just the distance from the top of the stack. Okay. And so anyway, what we can do is we can go ahead and look at iterators, and we can go ahead and look at enumerations, and then we can also look at listIterators, okay? And so we're going to figure out how to create and use those things. But we can go ahead and push some doubles onto the stack. So we could say 48.2, and then we could say numbers.push of 26.9, and then we could say numbers.push of double.parseDouble of 3.concatenated with 7.concatenated with point.concatenated with 1. And so basically that would go ahead and combine those 4 string objects into one string object that represents 37.1, and then you would go ahead and parse that, right? And so then you would actually make a double out of a string, and that's one of the methods that we talked about, I think, in lesson 7. Okay, and then we could also think about another one. So we could say numbers.push of, what if we say 15.7 plus 100, right? But these would just be random. And then what if we say System.out.println of numbers.peak? Okay, and so presumably this would return 115.7, right? Because that was the element that was most recently added onto the top of the stack. But anyway, just as a simple review, we could go ahead and take a look at that, but that would be 115.7. Okay, but then if we go ahead and pop it off the top of the stack, then it would no longer be the top of the stack. So then if we call numbers.peak after popping off 115.7, we should instead see 37.1 as the new top of the stack after we removed one of the elements, right? And so we would pop off 115.7, but then we would peak at the new top without removing it. So we would just peak at the 37.1. But anyway, we can go ahead and push a few more elements onto here. So we could say numbers.push of 3.3333, and then we could say numbers.push of math.pi, and then we could say numbers.push of math.log10, of 1000. And so that would essentially be 3.0, right? And then this would be like 3.1415926, so on. But if you didn't remember, you can go ahead and look at the Math Java API, right? And you would go ahead and click on the first link. And you would remember that the math class provides two important constants. One of them would be the base of the natural logarithm, and the other one would be pi. But now we have 7 elements added onto the top of the stack, and we could create an iterator based on them. So we could say iterator of type double, and then we could say number parse equals, and then we could say numbers.iterator, right? So hopefully that's clear to you. And then what we could do is we could say while number parse .hasNext, and then we could say something like System.out.println of number parse.next, and we could figure out how the iterator is going to treat the elements in the stack. Is it going to print them from top to bottom? Is it going to print them from most recently added to least recently added? Or is it going to do the opposite of that, right? And so hopefully that makes sense to you. But what we could also do is we could say number parse.remove. So this is a method that we have available. So optionally, this void method removes the element from the stack that was most recently referred to by number parse.next. So just whatever element you just called, whatever element is being referenced by number parse.next, that element literally gets deleted from the stack, right? And then we could basically see if the stack is empty at the end. So we could say some system.out.println of is the stack empty, right? And then we could basically say, and then we could say numbers.empty. Remember, with a lot of data structures, we have to say is empty, but for some reason with stacks, it's just empty, right? So then we can go ahead and look at the vector function. And so basically we can think about how these elements got treated, right? But we got 48.2 and 26.9. So it kind of seemed like it iterated them according to the order in which the elements were added, right? But then what if you had done a different operation, right? So what if you had done, but the stack does get empty by the end, right? But then you don't have to remove the element. What if you said number parse.pop? What if you just popped elements off the top of the stack, right? And then you could, but then you would go ahead and say, I guess you wouldn't be calling pop on the number parse. You wouldn't be calling pop on the iterator. You'd be calling pop on the stack, right? And so you could say system.out.println of numbers.pop, and then we could go ahead and it would print the elements in reverse order, right? So the top will be 3.0, right? And then pi, and then 3.33, and then 115.7, but the stack would still get empty, right? And eventually this Boolean would no longer be true after we popped all 7 elements off the stack. And so then we can also think about an enumeration. And so then what we're going to do is we're going to replace this. So we're going to say enumeration of type double, and then we could say number enumeration. That's kind of a long name, so let's just call it enum. Okay, and then we could say numbers.elements. Okay, so this is how you create an enumeration. You have to remember to import java.util.Enumeration. And then if we go ahead and remind ourselves of what the API would be, we can go ahead and look at the enumeration interface. And basically it's very similar to the iterator. The only problem is that it does not provide a remove operation, and the method names are longer, right? So now instead of saying hasNext, we have to say hasMoreElements, right? Instead of saying next, we have to say nextElement, right? And that's slightly less convenient, right? So if you're calling it a lot, that's going to eat up little split seconds, you know, here and there. And so it's just nice to have an iterator where we have shorter method names, but that's not what we're really talking about this video. We're talking about the enumeration. So we're going to say enumeration double enum equals numbers.elements, right? And then instead of saying, well, number parse.hasNext, we're going to say, well, enum.hasNext or has more elements, I think, right? So according to the API, that's what we would call. So we would say has more elements, right? And so then it would function the exact same way. We could still say system.out.println of numbers.pop, right? But you could go ahead and figure out what would happen here, right? So now if you call vector function, it has the exact same effect using an enumeration instead of an iterator, right? So the iterator's gone now when we're using an enumeration for the same effect, right? And then we could also say enum.nextElement, right? Now instead of calling .next, you have to call .nextElement, right? Because that's what happens for an enumeration, right? And then you would go ahead and run it. And then it kind of does the same thing as .next did for the iterator, but it seems like it sort of parses the elements in the order that they were added rather than in the order that they would be removed. And then we can also think about, there's one more structure that we want to talk about. So hopefully the difference between enumerations and iterators is clear to you. Okay, so either import java.util.Iterator or java.util.Enumeration, and then call hasNext for an iterator. And then, so then to create an iterator, we call .iterator, okay? And for an enumeration, we call .elements, right? So hopefully that's clear to you. And then hasNext for an iterator, and hasMoreElements for an enumeration, right? And then we would also say next for an iterator, and nextElement for an enumeration. And then the last difference is that we have remove allows an iterator to remove the element just referred to by next from the corresponding data structure, but that's not something that you can do with an enumeration. We also need to think about one more class that we have, and it's called listIterator, okay, and it belongs to Java, okay, so we're going to say listIterator. And so it's just like an iterator, but it's going to basically provide more operations for iterating through the elements in a particular data structure. So one of the questions you might have had up to this point is that we already know how to iterate from the beginning to the end of a linked list, for example, right? We would just call iterator, and it starts at index position 0 and goes to the end of the linked list or the array list or the stack. But what if we wanted to go in the reverse order? So what if we wanted to basically see if there were a previous element and get the previous element? So this is an iterator for lists that allows the programmer to traverse the list in either direction, modify the list during iteration, and obtain the iterator's current position in the list. So that's kind of neat that you have this additional functionality that we did not have in the traditional iterator. And it doesn't have a current element. So the way that it works is that its cursor position is actually just sitting nestled between two elements. Okay, so you're either talking about a next element or a previous element, but there's not really a current element. Okay, so it's just between the next element and the previous element, and there's methods that return the elements for both of those, right? So there's a next element which would return the next element in the list and advance the cursor position. But if you call the previous element, the previous method, it returns the previous element in the list and moves the cursor position backwards. So what we can do is we can try some examples here, right? But there's also a hasNext and a hasPrevious, right? And so hasNext would return true if the list iterator has more elements when traversing the list in the forward direction, and then hasPrevious would return true if there's more elements if you traverse it in the reverse direction. And then apparently you can also set and add elements, right? So you could insert a particular element into the list. It's an optional operation, right? Like in order to iterate through a list, you wouldn't really have to be adding elements to it necessarily, but this is kind of cool because now you can use your listIterator to actually add elements to that list, kind of like you used to be able to use the remove method of the traditional iterator to remove elements from the list, but you can still do that here. So it removes the element removes from the list the last element that was returned by next or previous, and this is another optional operation. But instead of talking about all this stuff, let's go ahead and do an example. So let's do it on a linked list. Let's do it on a linked list of integers. So we're going to say linked list of integer. We'll do it with numbers again, equals new linked list of type integer, right? And then we're going to say, we're just going to add some quick numbers to it, right? So we could say numbers.add of 571, numbers.add of -2, numbers.add of 10, numbers.add of 303, numbers.add of 11, and numbers.add of 28, okay? And then what we're gonna do is we need to go ahead and remember to import java.util.LinkedList, right? And so we're just up here at the top of our class conveniently, so hopefully you can see this, but we would have to go ahead and remember to import this, right? So that's something you have to remember to do. I guess one of the things I forgot to say is you need the word new here. So linked list of type integer numbers equals new linked list of type integer. And then we have to add those 6 elements onto the linked list. Okay, so don't forget that word new. So it's linked list of type object, name of the linked list equals new linked list of type object, parentheses, semicolon. That's it. So then anyway, what we're going to do is we're going to try some different things out here. Let me add one more. So numbers.add of 1,000. Okay, and then what we're going to do is we want to basically create a list iterator. So we're going to say list iterator of type integer, and then we're going to say number parse equals numbers.listIterator. Okay, so this is how you create a list iterator. So you say list iterator of the object type from list, object type from list. It's like the data type that the list is based on that you're going to create the list iterator based on, right? But then you would say name of list iterator, right? And then you would say, you know, list dot list iterator, right? So that's pretty wordy here, but hopefully the architecture there makes sense to you. And now what you can do is you can look for next and previous elements, right? And then you could also replace the last element returned by next or previous with the specified elements. We're going to see all kinds of examples of this. But what you could do is you could say System.out.println of number parse.next. Okay, and then we could go ahead and print that 3 times, right? So we're going to say number parse.next, number parse.next, and number parse.next. Okay, and so then if we go ahead and compile it, we're already going to be able to see the examples of one of the methods that we have here. So then we just get 571, and then we get -2, and then we get +10. What if we say number parse.set of 700, okay? And then what if we say, okay, so then what we're going to do, actually, instead of showing that, then we're going to say System.out.println of number parse.previous. So now what we're going to do is we're going to call the previous method and see what the result of that would be. So that has the effect of traversing the list 1 index position to the left. So it's actually going to go backwards, and that's new functionality that we have available to us when we use the list iterator that we did not have available to us when we used a regular iterator, right? So hopefully that's clear to you. But you could also get the next index or the previous index. So that would return the index of the element that would be returned by a subsequent call to next or previous, respectively. So hopefully that's clear to you. But what you could do is you could say something like System.out.println of number parse.nextIndex, right? And you could go ahead and see what index position it would be at, right? And then you could call that here too. So you could say number parse.nextIndex. Okay, and so that will basically, so after doing previous on the next line, what cursor position will we be at? So that's essentially how the next index method works, right? And then I guess we probably could have done this in a for loop, but I just want to show you some of the different functionality that we have available to us, right? And so then this would be calling next, right? And then after doing next on the previous line, right? So hopefully that's clear to you, and we just want to see some examples of how this is working. So then if we call the vector function, so here the next index position, so you start at the beginning of the list. So we have 0, and then we get 571. And then we're going to have 1 for the next index position, and then the element at that index position is -2. And then our next index position is 2, and then we're going to have 10, right? And then we're going to have the next index position here would be 3, right? But then we're going to call the previous. We're going to call the previous, right? And then we would say System.out.println of number parse.nextIndex. Right, so then if we go ahead, let's go ahead and add one more line of code here. And so then we would get index position 2, right? Because then if we go to the next index after doing that, we would be looking at index position 2. But the point is that a list iterator can be used to iterate through the elements in the forward or reverse directions, right? What if you wanted to print the elements in the reverse order? So you would just say while number parse dot has previous, and then you could say System.out.println of number parse.previous. So hopefully that's clear to you. Okay, and so then what we could do is we could go ahead and compile it, and then we could go ahead and run it, and nothing happens. Problem with this command is that we just saw that we start at index position 0, so there wouldn't be any next elements. But what you could say is number parse.hasNext, and then number parse.next, and then you could go ahead and have very, very similar code, right? Because then eventually you'll be at the end, right? And then you could say, well, number parse.previous, System.out.println of previous, of number parse.previous, right? And then you could go ahead and run it, and then it would print the elements from forward to backward and then backward to forward. So the point is that a list iterator can be used to move forwards or backwards in a particular list rather than an iterator which can only move forwards. From UMOSO 3, thanks for watching, and please subscribe.